All right, so let's start to set up the simulation itself. Grab from our construct thing here the RBD unpack and RBD exploded view. Just copy that. And let's make a new one of these nodes. We'll call it sim. I like to make my sim nodes purple for reasons that I do not fully understand. But in any case, come in here, Control V, paste these in, and let's do an object merge, feeding into at least this. These exploded views will always be just kind of visualizers hanging off the side, but let's kind of organize it like that. So go into construct and get the out node here. And there you go. So what do we have? We have all of our pieces now, or at least we do after our RBD unpack. Make sure that it has these two things. We need the part attributes, and we like to have the color. So with all the pieces here, remember, we're only going to simulate the proxy geometry, but we're still keeping the regular high-res geometry along for the ride. So the next thing we need is an RBD configure. You might recall that we did an RBD configure earlier, back in the fractures themselves. That's fine. It won't repack anything. Back here when we did it, we went from having, the raw polygons and points to them being packed up based on their names. Once we're here and we have our RBD fragments with all these attributes, let's just say, and I hook this up, it's not going to pack them up again. You can see it's still the same attributes here. If it had been packed up again, you wouldn't see these anymore. This has a little switch inside of it that knows, both on the high-res and on the proxy side, it has a switch to see, are these already packed or not? So the point is, don't worry about using it again. This will just be a nice place to set various simulation parameters in one centralized location. So if I want to change any of the physical properties, for example, I want to make them less dense or a higher bounce or change the friction, I just need to enable a thing and I can change it. So that's cool. In our case, we're going to play with the active versus inactive attributes, but we're going to do that a little bit later. So first, let's actually just put some nulls here. I'm going to say this is our high res. The middle will finally actually be our constraints once we make them. In fact, we can go ahead and delete that. I mean, I don't think there are any constraints coming in here anyway. There's not. Remember, before we said not to back here. So high res constraints, and I could either put low res here, or I could put proxy. I'll do proxy because that's what Houdini calls them. So again, if we look, we can see these are the standard Voronoi shapes. If I look here, we can see it's the similar looking high-res shapes. They have the same name attributes, much like we saw, I believe, in Rigids 1. We will move the high-res ones based off the low-res ones. So with that set up, let's actually make a dot network. So there it is, dynamic operator network. And I'm going to just hook them in the order that they already are, which doesn't do anything inherently because there's nothing inside here. But we can refer to those inputs once we're inside. So RBD packed object. I should also say really quick, we talked a little bit about the RBD fracture, or the RBD bullet solver, SOP, meaning on this level. Oops, put it there by accident. This is not any different necessarily than what we're going to set up, but it does have way more stuff than we need, first of all, and it's a little harder to modify. We need total control for what we're doing right now, so we're going to build it ourselves, and it's just better to learn this way anyway. So here's the RBD packed object. This is what's going to read in our geometry and keep track of our geometry as the simulation progresses. So the source is the third context geometry. It's the third context geometry because it is the 1, 2, third input. It's the proxy pieces that we're simulating. So there it is, RBD packed object. What else do we need here? We need the actual rigid body solver. Make sure it looks something like this, where we have the bullet tab. You could use a bullet solver. Definitely don't use the RBD solver. This is the very old solver that Houdini has. Don't use that. Although it is good for some things. In any case, so we have this, which stores the data, this, which solves the data, meaning it determines the collisions and evolves the simulation forward. And what else we need? We need gravity. We need a ground plane. Ground plane is just instead of it being like polygonal geometry that says you're colliding with this specific shape, a ground plane just says, hey, if I'm just an implicit plane that goes forever in every direction. It looks like it's just this platform. It's not. These arrows are meant to suggest it really goes to infinity. This is just a symbol. But in any case, this merge will do a collision. So I'm going to have, that's weird, put it in like that. I like to just set this to be mutual. That means that technically our rigids will affect the ground plane too. But the ground plane can't actually move, so it doesn't really matter. I put mutual just to make sure I don't get it wrong. If I put left inputs affect right inputs, but the order that they're put in here is like this, then nothing's going to happen. So just have this be both. Whatever. It doesn't matter. And there you go. That's pretty much it. As far as a simple setup goes, that's all we really need. So if I press play, we'll see something happen. We'll see it just slowly collapse. In fact, I'm going to make this as a flipbook, and then we'll reconvene when it's done doing this.